I started on Hadoop before it was Hadoop. I was originally the architect for MapReduce, working with Arun and Devaraj when they were in Bangalore. Then I became the architect for security and took that through completion. And now I'm working on Hive. Hive was created because Facebook, who were the original creators of Hive, had this need for people who wanted to analyze data at large scales to not have to write Java programs. If they were willing to write Java, then they could use MapReduce and make that work. But if they wanted to use SQL or a SQL-like language, then teaching them Java and how to do MapReduce was a very high learning curve. Hive works by taking the user's query and breaking it into a logical plan, mapping that plan onto MapReduce jobs and running those jobs in succession. So it'll submit the first job, wait till it gets the results, and submit the next job, and so on. Part of what it provides is it gives you a nice way to register your data and keep track of the format of the data. So you can say, okay, the table had this many columns until this date, and then after that date it has 3 new columns, so that if you look at the old data, those columns now exist but they're null. And if you look at the new data, it of course has the columns that you added. So what's the future of Hive? In the short term, we're very focused on making the performance get better. Hive does a good job of always getting the job done, but we want it to run faster and get your answer more completely. Now, it's important that we want to achieve that performance without giving up the thing that makes Hive Hive, right? We don't want to make it so that it can only run on data sets that fit in memory across your cluster. That doesn't work for our customers. Our customers have more data than fits. I've got a customer that has a customer table that's 10 terabytes of data. That's too big to fit into the RAM on the cluster, and they still need to process it. And that's just the customer table, right? Crossing that by the sales table, and you have way, way too much data to fit into a reasonable amount of memory. We also are working on integrating it with Tez. Tez is our extension to MapReduce that lets you have a much richer computation model than just the MapReduce chains that we currently have.